Okay, I think we're going to get going. Thank you all again for joining. Welcome to the webinar about the Intrinsic AI Challenge. I think most of you probably know the general gist of what this challenge is about since you're in this the seminar. I want to start by introducing myself. I am Geoffrey Biggs. I am the CTO at the Open Source Robotics Foundation. I'm joined here by my friends Jimmy Baraglia and Yadu Vijay from Intrinsic, and they are co-hosting the seminar with me. I'm very, very excited to see this this challenge kick off. It's been really exciting to see it come together. We've been involved in challenges at Open Robotics for many years, probably going right back to our founding, and we've seen just how amazing they can be for bringing people together, for bringing collaboration out, for triggering people to solve really complex problems. I mean, we've seen some amazing challenges over the years. My favorite is the sub-T challenge, which we did a few years ago, where people were sending robots into mine shafts to try and find stranded people. It was amazing to see, and so I'm really looking forward to seeing what this challenge brings out in terms of industrial AI. And we're also very proud, of course, of how pivotal a role open source robotic software such as ROS and Gazebo plays in these challenges. Because these tools are free and anyone can use them, you know, they really allow everyone to take part in challenges and to see what they're able to do. So a bit of a housekeeping announcement before we really dive into things. We're not going to have a live Q&A during this session. In order to make sure the information is recorded and everyone is able to take advantage of the answers, we're going to be collecting questions that you have during the seminar and posting them on Discourse along with answers. So if you have a question, please put it up in the chat and we'll be able to record that and we'll get an answer to you via the Discourse threads. You'll be able to see the response there along with everyone else. So without further ado, I'd like to hand it over to Jimmy to take it over for the seminar.
Thank you so much, Jeff. And thank you everyone for joining into our webinar for the AI for Industry Challenge. So we are really, really excited to with you be kicking off this unique opportunity for teams around the world, throughout the US, Europe, Asia, to kicking this challenge and challenge themselves and bring the best of AI and robotics to cable handling. So during this webinar, Yadu and I will cover the essential for you to understand the task, how to register your team, when each phases will happen, and then Yadu will cover how you will be evaluated, give you an in-depth view of our toolkit, the submission portal, and the leaderboard. Throughout the webinar, we ask you to stay muted, don't raise your hand, don't use animation if you can, and we'll answer your Q&A offline after the webinar or on the Discourse channel, as Jeff just mentioned. So let's get started.
Let's do it.
Let's do it. So why are we here? So we are at a really historic inflection point in AI journey. The demand for AI infrastructure has been boosted by recent AI advancements, and the number of data centers is climbing to unprecedented height. This requires increased also manufacturing operations, and our physical capability to automate some of these tasks can't keep pace as today with the today's technology. So this challenge isn't just about incremental gain. It's about bringing state-of-the-art AI and robotic to this new wave of electronic manufacturing, and especially to cable handling. So we are inviting you to solve the unsolvable, mastering flexible materials such as cable, detecting small connectors and insert them into a highly unstructured environment. And this, in turn, will help power the next generation of global automation. So during this challenge, you'll be able to register your team. Reminder that we have a deadline for registering the team on April 17th. And we are also welcoming partners to this challenge. So you've just met Jeff from Open Robotics. We're also working with NVIDIA and Google DeepMind. And I think Yadu will tell you more about that in the later slide. Now, this challenge comes with a significant prize pool of $180,000 that will be divided between the top 5 teams. the team that plays first at the end of the challenge will receive a staggering $100,000. The second team will receive a very good $40,000. The third team, $20,000. The fourth and the fifth team, we both receive $10,000. Now, this will be a really competitive challenge, so we're looking forward to see who the top 5 team will be. Now, what task are we asking you to do? So in that context, we are really looking at a high mix of cable handling and insertion. So we took inspiration from data center. We took inspiration from server assembly and build a task board that reflects both of these aspects. So there will be a high mix of cable type, 2 or 3 cable type with multiple connectors and an network interface card. And this kind of represent what we've seen. And why is this task difficult? Well, detecting different component, handling cables, high mix environment is really difficult. And there is also a very high cost of error. If you fail just one cable insertion, or if you damage one component, a whole server can be compromised, or a whole set of server will be unavailable for the AI inference. And there is also a lot of complex tasks about modeling this high contact manipulation task and manipulating object with deformable component. And so you will be tasked with developing a flow policy and robotic behavior to solve this challenge, to manipulate and insert various type of connector, providing an end-to-end automated solution for this electronic task using that task board. To do so, you will train an AI model using open source simulators. So we'll provide you with tools for Isaac Sim, Mujoko, and Gazebo, as well as leveraging ROS for communication. And I think Yadu will talk about that a lot more in depth once we get into the toolkit section. This will be also your opportunity to show that your model can bridge the gap between sim to real, not only working in simulation, but also make tangible incremental progress on real-world problem. Now, we received a lot of email about team registration, so I'm going to spend some time on this slide. So again, important action, make sure that all your team members are registered individually by April 17th. There is a QR code on the slide. You will receive the presentation, the recording, and also you can go on our website, intrinsic.ai, and follow the instruction on the landing page. Teams can be up to 10 participants. That's our limit. You can create or join only one team. So we are going to check to make sure that one participant is part of multiple teams. One person will be designated as a team leader, and they will be responsible for managing the team submission on the portal. Only the team leaders will receive the login credential to the submission portal, and you will receive that via email by end of March. So don't worry if you don't have it today. It will come by the time the submission platform will be open. Now, the registration and the qualification phase is open to everyone, but only eligible team will be able to move on to phase 1 and phase 2 and complete the whole challenge. So make sure that you have read our term and condition in full and that you understand this limitation. Now, like I say, we receive a lot of email about teams, especially about team flexibility, adding member to your team, removing member, changing leader. So you will be able to manage your team change directly from the submission portal at any point before the submission deadline. We recognize that the current process is not really flexible. We received a lot of requests to do this change. You do not need to email us about making this change. Once you get access to the submission portal, you will be able to do this change. And the access will be emailed to your team leader, again, by the end of March. So we just ask you for a little bit more patience on that front. Now, some people are looking for teams, they don't want to do the challenge on their own, or they want to find like-minded people or complementary skills. We have set up a discourse for you, so you can access through the QR code. I think you can also Google us or look through the website for the link. There are already a few people that I think that are looking for teams, a few teams that have been formed. So don't be shy, go to the link and talk to your fellow participants. Okay, so looking at the timeline, this challenge started yesterday. Gonna be more excited about that, and will run throughout September of this year. It will be divided into 3 phases. So we are currently in the qualification phase, where you will start training your model, and then you will test them on simulation. So you can use any tool that you prefer to train your model, or any simulation that you prefer. We're going to provide, like I said, Isaacsim, Mujoko, and Gazebo, but you're not limited to that. It's really like, we're looking forward to see your creativity into creating a model. However, all the models will be evaluated using our submission portal that is powered by Gazebo. And I think, again, Yadu will provide a lot more details on that. So this qualification phase will run from March 2nd to May 15th. And after that, we'll have an evaluation period, and the top 30 teams will be announced on May 28th. Now, this top 30 team will qualify for phase 1. At this point, you will get access to intrinsic flow state, and you'll also get access to all our capability, including our intrinsic vision model, which we're really excited about. And using flow state and intrinsic vision model, you will integrate your model into an end-to-end robotic solution that you can deploy in simulation. This phase will last until July 14th. Again, we'll have an evaluation period, and the top 10 finalists will be announced on July 23rd. At this point, you will be able to deploy your solution on real hardware. You'll be able to take time to refine your solution to run both in simulation and on physical hardware, and then you will be receiving final evaluation by August 25th. And we'll be really excited to announce the winner on September 8th. Now, a quick preview of what the hardware setup would look like. So we cannot be more excited about building these cells and sharing it with you. And I hope that you join us in being excited about this. All right. Last but not last, I want to introduce our evaluation committee. So as I mentioned, the goal of this challenge is to show how AI, open source tools, and the intrinsic platform can add value in real-world use cases, and bring these solutions into the real world, not only in labs, but actually in automation factories. This committee is a representation of the full automation ecosystem, from AI to robotics to open source and factory automation. And they will ensure that the finalist submission follow the vision of the AIC challenge, and that this vision is well represented in our winning team. Now, let me introduce each of these amazing judges, starting with Amit Gol, which is the Director of Product and Autonomous Machine at NVIDIA. Siddharth Nordinger, which is the Head of Ecosystem EMEA for Universal Robots. Dr. Zelshi, which is the Chief Digital Officer at Foxconn. Geoffrey Biggs, which you met earlier, which is the Chief Technical Officer at Open Robotics. Francesco Noli, which is the Director of Robotics at Google DeepMind. And finally, Wendy, the CEO of Intrinsic. All right. Now I'm going to hand over to my esteemed colleague Yadu, who will tell you more about how your solutions are evaluated.
Thank you, Jimmy. Warm welcome to everyone joining us on this call. It's really nice to see so many of you up early, staying back late to attend this webinar. My name is Yadu, and I'm super excited to walk you through some technical aspects of our toolkit, starting with how we'll be evaluating teams. Now, this slide summarizes our evaluation philosophy, which is a hybrid approach. We're going to have some automated scoring together with qualitative metrics that are coming from our evaluation committee that Jimmy presented. Looking at the automated techniques, we'll be deploying this for the qualification phase in phase 1. Together with phase 2, we'll rely on certain services and other backend systems to be able to track how well your model is performing, whether it's in sim or real. And we'll go over some of the metrics that we'll be closely tracking, as well as bad behaviors that we'll be penalizing later in this presentation. Coupled with that, for phases 1 and 2, we will have this qualitative assessment done by our expert panel of judges. And again, what's more important there is checking for viability for real-world deployments and making sure that your solutions can actually see the light of the factory floor one day. All right, with that, let's jump into the toolkit. I'd love to give everyone a quick overview of the toolkit itself. By now, all registered participants should have received an email with a link to the toolkit. If not, please scan this QR code on the top right corner. And before we jump into that toolkit, I just want to give everyone a highlight of what to expect. Now, this toolkit is something that you'll be working with throughout the different phases of the challenge. But today, it mostly contains information related to the qualification phase. Inside the toolkit, you'll find a rich scene description. Now, this includes high-fidelity assets related to the robot, the environment, the work cell enclosure, the sensors that monitor on the robot, together with electronic components that you'll be interfacing with. This is the task board, the cables, and other components that you'll be picking up and placing. We're using ROS as the data backbone for this challenge. All sensor data from cameras, force torque sensors, robot states will be piped through ROS, specifically ROS 2. And we're choosing to build off the latest release of ROS 2 here, Kilted Kaiji. Participants will also be expected to develop a ROS-based policy, and we'll go over some of those exact requirements in just a moment. Together with that, you'll also find some really powerful capabilities that Intrinsic's offering as part of the toolkit, starting with a very nice impedance controller that respects both joint and Cartesian commands. We'll also see other capabilities throughout the different phases of the challenge. To help participants get started, we're also providing some template code and examples for you to understand the task at hand and kind of get you started in implementing your policies a bit easier. To also support your development, we're providing our scene descriptions in other simulators, namely Google DeepMind's Mojoko, as well as NVIDIA's Isaac Lab. And the idea is that with the scene in these environments, participants are free to use their own creativity and tooling from our sim partners to be able to generate more robust models. However, all simulations will run in Gazebo for evaluation, and this will be the simulator of choice across the different phases of the challenge.
Okay, well, that's really great, Yadu. I guess that everybody will join me into wanting to see the toolkit now.
Yeah, it's been a lot of talking.
Yeah.
Let's show them what's actually in the toolkit. So I've switched over my tab to the toolkit repository itself. This is github.com/intrinsic-dev/AIC. So please follow along, or you could use this video as a reference after this presentation. So once you open up our toolkit, you should arrive at this nice landing page, which describes a lot of information. Throughout this webinar, we're going to focus on this toolkit guide section, as I feel this contains a lot of information for participants to understand the challenge, try to understand what's in the toolkit, and provides them also with some guidance along the way, which would be beneficial. Before we jump into those exact links, I'd like to take the time to describe the architecture. Now, again, this is the architecture we have for the qualification phase, and we've made it really simple for participants here. There are two main components in our toolkit: AIC eval, or the evaluation component, and AIC model, or the model component. Now, the AIC eval contains the Gazebo simulation environment, including the robot arm with end-of-arm tooling, all of the sensor drivers that we need to pipe data to and from the robots. It contains the task board, the electronic components, and it contains what we call the engine to orchestrate all of these as part of the competition. All of this is provided by us. Participants don't have to modify any of this. We'll provide them a Docker container which they can use to run all of these systems. What participants will be tasked to do is implement and package something called the AIC model. Now, this is going to be a ROS 2 node that will have to respond to certain signals from the evaluation container, signals relating to a task request, to know when the task is completed, or any feedback along the way. And we'll get into more about the requirements in just a second here. I do encourage all the participants to spend quite a bit of time studying the toolkit. There's a lot of information and documentation here, and it's going to be worth your time going through all of this before asking any questions. Should we jump into the overview, Jimmy?
I would love that. Let's do it.
All right, let's do that. So I'm going to click through the different sections in the toolkit guide, and point out some important information that'll be relevant to participants. Now, Jimmy, you just covered a lot of this information that's part of this overview document, but this is, again, just letting participants know if they want to find that information on the timeline, the different phases, how we'll be doing evaluation, how they'll make submissions, and some other information.
Absolutely.
They can come back to this document right here. But to begin with, I'd like to jump into the competition phases section, and more specifically, talk about the qualification phase itself. Now, what do participants have to do? By the end of this challenge, by the end of phase 2, we want to be able to develop end-to-end processes for cable insertion. But for qualification phase, the scope is much narrower. We're simply evaluating the ability for participants to develop certain policies that can do a last couple inches of insertion. So the idea is that participants take our toolkit, they're able to train a model. This could be an AI-based model. It could be using some classical control algorithms. We're not prescriptive of the actual technique. What's important is that the container or model that participants generate respect certain commands and signals from our side. They could use Gazebo to test how their model locally using the same scoring system. And when they're happy with it, they can make a submission to our cloud instance. And in the cloud, we're going to be running the exact same Gazebo environment together with their container. And we'll be standardizing the compute specs of this eval instance to level the playing field for all our participants.
So everybody will be evaluated with the same.
Exactly, Jimmy. That's a very important point. All right, so I'll just quickly scroll through the rest of this document. We have some very technical overview for participants, together with information on how to get started with developing their policy. Let's jump really quickly into more details about the qualification phase itself.
Yeah, and at some point, I'm really curious also, like, if you can tell about how accurate the simulation environment will be for the participants.
Absolutely, Jimmy. This is an important point to clarify. I think we recognize that no simulator out there perfectly emulates the physical world. They're all very good at their own different attributes. And we want participants to make an informed decision on what simulation to use. And they're free to even combine data from different simulators. In fact, we're seeing a lot of state-of-the-art work coming from techniques like sim to real, where participants gather data from different simulation sources to sort of randomize the noise in the real world.
That's quite innovative.
Yeah, we're also looking for some innovative solutions from participants here. All right, so let's jump really quickly into the qualification phase itself. So here's the scene for the qualification phase and the rest of the challenge. You saw a really nice render of the physical work cell. The team has gone into great lengths to produce a very, very good quality digital twin of that same physical cell in this environment here. So participants will have the ability to load this scene, and they'll be able to load different versions of the task board. We provide them with scripts to randomize this task board. They can spawn it with different configurations, different components, different locations in the scene. So I encourage participants to spend some time looking through the scene description. The robot of choice we have is the UR5E. This is equipped with a custom end effector that has 3 RGB cameras mounted on its wrist in a radial fashion, has a ATI force-torque sensor, and a pinch clipper. There's a lot of good information here on the task board itself, and it's worth jumping into the description of the task board for participants to get familiar with. Now, as Jimmy mentioned, we've gone into a lot of trouble in designing a task board that represents average components you would see in server manufacturing, but make it also more accessible for participants if they wanted to 3D print some of these components.
Okay, so you would recommend participants to really study this page if they want to learn more about the task?
Absolutely, Jimmy. Important are these annotations that we have on the task board. Now, we'll be giving participants a specific task description. Here's the task you need to do. You need to insert this cable, which has this plug, into this port on this component. And what does all that mean physically? That information can be derived from this document. So as you scan through this document, you'll get an understanding of the different zones on the task board. We have 3 main zones. Zone 1 is where the network cards will be placed. And during the challenge, we will spawn 1 or more network cards. But the insertion task will always be a single insertion that needs to be done. And what's important for participants to know is when we say SFP port 1 on NIC card 1, what does that mean? And I'm hoping this document can provide that information to participants.
This is really clear.
Similarly, they'll also have access to descriptions of other zones. We have SC ports that are placed in zone 2, and we also have some notation to clarify the names of these ports. So I do encourage participants to spend some time going through the task board description. It's going to be very critical to their success of their policy. We also provide some links for them to purchase some of these components if they're interested in, but for the most part, they should be able to work successfully in simulation.
And I think the 3D model will be available within March, correct?
Absolutely. All right, so once you're a bit more familiar with what's in the scene description document, we provide some guidance on how to explore this using some teleoperation scripts that we provide. So I'd encourage all participants to spend some time spawning different task boards into the scene, moving the robot around, getting a feel for how the cable behaves. And while they're doing so, they can rely on their favorite introspection tools in the ROS ecosystem to be able to subscribe to data from cameras, from force-talk sensors, to really get an intuitive sense of the behavior in simulation. Also part of the screen description document is a way for you to conveniently convert the scene in Gazebo to any other simulation. Now, out of the box, we're providing some converters to Mujoku and Isaac Lab, but participants are free to use similar workflows to convert it to any other simulator of their choice. So just as an example, by clicking through the Mujoku guide, participants will be guided through the process of converting the Gazebo scene to a Mujoku scene and being able to control the robot using the same ROS2 interfaces. All right, with that, I'm going to jump back to the qualification overview document. What's important to clarify is the scope of the task. I think we've stressed this a couple of times. We'll be conducting several trials. In each trial, participants will have to do a single insertion only. The initial state is very narrowly constrained. The robot is always going to be holding on to one end of the cable, and there will be no unseen port or plug types. Whatever you will encounter in the challenge is already in the toolkit in our assets directory. So it's worthwhile for participants to explore the assets that we have.
The idea that they can then focus on the model for this phase.
Precisely. And just a quick note on how the task will be described to participants. We have this ROS2 action request, which we'll be sending to participants when we want them to start doing the insertion. And when we look at the fields in this message, they're mostly relating to the type of cable that's in hand, the type of plug that's in hand, the port we want to insert it into, and the component in which this port exists. So together with that information, participants should be able to engineer to fulfill this task. A quick note on the orchestration engine. So we have a process called AIC engine, which will be responsible for basically running the challenge. It will be spawning the task board into the scene, spawn the cable, and attach it to the robot gripper. It'll then give the task to participants to execute. And all of this can kind of be configured in a config to pass to the AIC engine. So that's also an important document for participants to look into. The remainder of this document details what the initial conditions look like for the different trials. We'll likely be running 3 trials for evaluation. And for all of these trials, you will see some combination of these 2 setups. So setup 1 is with the SFP module grasped by the robot. And the task will be to insert this SFP module into one of the SFP ports on any one of these NIC cards. The second configuration participants can expect is grasping the other end of the cable. So now the other end has the SC plug, and now they will be tasked to insert this plug into one of the SC ports.
Understood. Can you tell us or tell the participant a bit more about how the submission will be scored?
Absolutely. Let's jump right into the evaluation metrics and scoring section. For the qualification phase, we have a tiered approach to scoring, and we have three tiers that we'll be scoring participant models against. The first tier is model validity. And here we're checking that the participant model conforms to certain challenge rules. And this is a good opportunity to go through those rules really quickly. So first and foremost, we really want participants to honor the spirit of the competition. As developers of this competition, we've done our best to try to restrict attempts to cheat and circumvent the system by blocking some calls participants can make to backend systems. But really, we want participants to honor the spirit, to be able to think of this as a difficult engineering task and come up with solutions that have potential to be deployed in the real world. We have some language here related to the prohibition of cheating, together with how we will try to limit some of this to the best of our abilities. But rest assured that all qualifying teams will will be assessed individually to make sure that their policies honor the spirit of the competition.
That's great, Yadu.
What's more important and relevant to scoring are the technical specifications of this AIC model container. Now, we don't want to be super prescriptive of what's running in this component container. It could be a Python node, a C++ node, maybe even a Rust-based node. What's important to us is that this container responds to certain standard signals that we expect. First and foremost, it has to be a ROS2 lifecycle node with a name called AIC model. It needs to honor and transition its states based on these expectations described here. When a task is sent to the model or the container node, it has to start doing that task and publish valid commands to the robot. And there are some other conditions here that we expect participant models to follow.
So it is a sort of like handshake.
Exactly, Jimmy. That's the right way to think of it. And based on whether they pass or fail at this stage, we'll be giving them a point of 1 or 0. If they fail at this stage, we will not be evaluating subsequent stages of the trial.
Understood.
Now, tier 2 is where we really measure the performance and the ability of participant models to converge towards a solution. And again, here are some quantitative metrics that we'll be tracking. We want to make sure participants are developing policies that have very smooth trajectories. And this is going to be really important for electronics manufacturing. Very tight spaces in which these robots actually operate. So we have some strict criteria for amount of jerks that participant models can produce.
To make sure that the robots are safe to work around.
Exactly. On that same topic, we also want to penalize participants for bad collisions, as these could be very costly and potential downtime on the line can be pretty catastrophic. So we'll be tracking some contacts and collisions between the robot end effector and the seam, and also the end of the cable, the plug that the robot's holding onto, and other components in the task port. So this would be a good document for all participants to get familiar with. And the final tier is task success. And something we should have mentioned earlier when we talked about simulation is modeling contacts is typically hard in most simulators. There's a lot of hyperparameter tuning that's needed. What we're more interested here in this stage is to see potential in participant models. We want to get a sense of, is their model generalizing to different types of cables? And we want to incentivize participants who develop models that bring the cable plug very close to the desired port. Now, if they're within certain vicinity of that port, they will be given a bonus. And if they do complete the full insertion, according to the physics in Gazebo, they will also be given a small additional bonus to that.
That's good.
So this way, we're really incentivizing them to find the right port and start doing the insertion.
So what happened here? You inserted into the wrong port?
Yeah, that's also something that would be catastrophic, and that's why we have a good penalty for participants whose models exhibits this kind of behavior. And finally, your total score for that trial will be the sum of these different tiers, and your final score for the entire evaluation will be the sum of scores for each trial.
I really like that. And so can you tell the participant how they can submit? How often, like, can they submit multiple times a day?
Yeah, we encourage participants to test as much as they want locally. As I mentioned, the evaluation container will be the same one that we run on our cloud instance. But when they want to make a submission to update the leaderboard, that's possible once a day per team.
Okay, so we have to make sure that the model is valid before uploading.
Absolutely, or else they'll have to wait for 24 hours.
That's good.
All right, I'm going to jump back to the main toolkit guide. And the next thing I'd like to cover are how participants can start actually integrating their policies.
Great, Yadu.
All right, so we're trying to make this competition as intuitive and easy to implement as possible for participants. We really want them to focus on the logic of the policy itself and not be too worried about the infrastructure or the data plumbing that's happening behind the scenes. For advanced users, people who are familiar with ROS and are keen to explore more of the backend, they could develop their models such that it adheres to the challenge rules. All we care about is that it's a lifecycle node in response to certain requests from our side. But to help majority of the participants, we've made it really simple for them by developing a node called AIC model that dynamically loads something called a policy class. And this is a base class that we provide in our toolkit. And essentially the task for participants is to implement a Python module that implements this base class. And if you look at the methods in this base class, they are essentially tasked to implement a single method called insert cable. This insert cable receives a few set of arguments. First and foremost, it receives the task itself. This looks like the message that I had shared earlier with those different fields describing the cable and the port. And they'll also provide it with some callbacks. So now these callbacks will make it really easy for participants to get the latest observation. And what's in this observation? It includes the current joint states, the end effector position, the value of the force torque sensor, 3 camera images, and the joint states of the robot.
Right.
So all of this is bundled into the observation message, and at any time, participants can query for this. Together, we also provide them with a callback that called move robot, and using this callback, they'll be able to command the robot to move in space. We recognize that participants might want to work either in Cartesian space or joint space, so we've actually engineered our controller to respond both type of commands. So using the toolkit and using some helper functions in this policy class, they will be able to tell the controller what type of commands that they'll be publishing. So this way we support both type of control formats.
That's great. And like for participants that are not experienced with software, are there examples of implementation that they can look at?
Great question, Jimmy. So this document provides a good overview of how to begin implementing your policy. I'll quickly scroll through this tutorial section that we have to walk them step by step in creating a new policy. And as a reference, they can also look at some of the example policies that we have as part of our baseline solutions package. So I'm going to jump back to our main AIC repository. If they click into example policies, they'll be able to see some implementations of policies that we provide as a good example. We have the wave arm example. We'll touch upon that really quickly in a second. We also have something called cheat code, which has access to some ground truth information. Now, this is a way to show participants what not to do. So during evaluation, they will not have access to some ground truth information in the form of poses in the scene. And this is a policy that makes use of that information to engineer an insertion.
So they could use that policy to collect data, for instance.
They could. That's a very valid use of this policy. Another policy example we provide is integrating an action an ACT policy, action trunking transformer policy. And this was something that we quickly trained using the Lay Robot framework. And that's becoming a really popular framework today in robotics. And I'm happy to share that our toolkit actually has some integrations with Lay Robot.
Oh, that's great.
So it's going to make it really easy for participants to teleoperate the robot, collect data, and train using existing tooling.
That's great.
There's also several other examples that we encourage participants to look through. Now, to wrap things up, I would like to walk participants through a getting started workflow so that they can get started as soon as possible, maybe right after this call. So I'm going to jump back into the main toolkit README and click through the Getting Started guide. Now, Getting Started guide expects participants to be familiar with the architecture of the toolkit. Now, this goes back to that main drawing we had in the README with the AIC eval component and the AIC model component.
You code here.
Exactly. Right. And together with that, we also provide some requirements for compute. So these are the minimum requirements for running the sim locally on your computer. And we also provide the exact specifications of the cloud instance. And this will be reused across all participants' evaluations. All right. As you skim through the Getting Started guide, you'll be asked to install certain dependencies. And we're trying to make it as simple as possible for participants to get started with. So we have this very nice quick start guide, almost like a hello world example, for them to quickly bring up the evaluation environment and quickly try out one of our example policies. And to facilitate this, we're actually publishing our evaluation component as a Docker image that they can pull. We're encouraging participants to use DistroBox to load this image, and this takes care of forwarding things like device drivers and kernel interactions, and makes it seamless to bring up GUIs and leverage your GPU in the background. So by following this quick start guide, you'll be able to enter the you'll be able to launch the evaluation component. You'll be able to see Gazebo with the robot visualizing the Arvis. And then you can try running one of our example policies. So for wave arm, for example. And this is a policy that's a bit of a Easter egg or a joke, I would say. It does nothing but wave its arm back and forth. And it's an example of how you could integrate a policy. And what do you think the scoring here is going to be, Jimmy?
I'm going to guess close to 1.
Yes, I think that's a good estimate here. You should see a score of 1 as it passes the model validity check, but it doesn't get anywhere close to the actual ports for insertion. Now, as you walk through this guide, you'll get some information on what you should expect on the different terminals. And once you have this set up, you will also be prompted to go through some of our baseline solutions and the rest of our documentations to get started.
That's great, Yadu.
All right, with that, should we jump to how submissions actually work?
Yeah, I would love to hear that. Thank you.
All right, switching back over to our slide deck. Once participants have developed their policies, they've tested them locally, and they've built containers out of these policies, they will be asked to make submissions on our submission portal. And we'll be providing a link to the submission portal fairly soon to participants. Once they have access to it, they will be able to start making submissions again once a day. Please reach out to your team leader to get this information, and please coordinate among yourselves on who will be making these submissions. My recommendation is there's a designated person to make these submissions on behalf of the team.
Or the team leader will be doing this submission.
Absolutely. All right. So once they make a submission, our evaluation engine will start running their policy together with the evaluation environment. It will be running the exact same code you see in the repository and generate a score using the exact same techniques. But we will have access control measures in place to prevent cheating as much as we can. Once the engine runs, the leaderboard will be updated with the latest score from the team. And this is an opportunity for you to also see how you do compared to other teams.
I see. So you can see your score in respective to other teams.
Absolutely. This is a competition at the end of the day, and we want it to be a fun competition for people. And we can't wait to see how teams try to edge one another off.
So once we've gone through the qualification, so who qualify? If I'm a participant, how do I qualify to the next phase?
Absolutely. So this will be based on the scores of the leaderboard. We're going to qualify the top 30 teams to the next phase of the challenge, but we will be manually vetting submissions from each of these teams to make sure we didn't miss out anything in our evaluation, to make sure that they honor the spirit of the challenge.
Right. So making sure that they don't use ground truth data
Exactly.
to play the game.
Precisely. All right. And just as a reminder for everyone here, if you haven't registered yet, please do so by scanning this QR code. You have up till April 17th, and qualification phase will run till May 15th.
May 15th, correct.
And I'm sure there's tons of questions you may have. We encourage everyone to ask questions on Discourse. Please find our AIC category on Discourse, and feel free to create a new topic or new ticket for your specific issue. I'm already seeing a lot of good questions coming in, but they're all piling in under maybe our post that announced the toolkit. And for improving the discoverability of your questions, it would be great if every participant can ask their questions in a separate thread.
And also, Yadu, it's a chance for participants to start building this community of developers that can work together to solve the challenge.
Absolutely. We firmly believe in accelerating a lot of this physical AI adoption through open source and through the community. So we want to make sure that we're helping each other along the way.
That sounds great, Yadu.
All right, Jimmy. I think we have a lot of questions that participants already asked us leading up to this webinar.
Exactly.
So we have a few of them listed on these slides. Should we walk through them?
Yeah. Let's start with team setup and general information. As mentioned earlier, for the team setup, you are going to be able to manage your team through the portal. So we'll provide you access before end of March. You do not need to email us about team questions. This will be resolved once you get access to the portal. And for any general information, you have access to our website, intrinsic.ai, to the toolkit as of yesterday, as well as Discourse. If there are any information missing or any question that you have that are not clear, you can also email us at challenge@intrinsic.ai. Yadu, what computers are available or required by the challenge in terms of evaluation?
Yes, so for evaluation, we did describe the exact specs of this eval instance in our Getting Started guide. So I encourage participants to find that information there. Unfortunately, we're not providing any additional resources at this stage of the competition. Once qualifying teams make it to phase 1 and 2, they'll be able to work on our cloud-based platform, FlowState.
The next question, I think, is a good one. Like, are there any resources that we provide for model training?
Yeah, not at this stage. So we'll wait for those flow state stages to provide those resources. But we really want to drive this idea of benefiting from the community. There's tons of open source resources out there that participants can build upon. They can also use their own capabilities that they've built themselves to solve this challenge. And we're really hoping that they can stand on the shoulders of giants here.
That sounds great. This is also a really good question. So in the toolkit, we say that toolkit collision is not allowed during insertion. It says that penalty will be applied during collision. This participant is asking if a wire tip slide along the socket, will the motion be considered as collision? Or is there a threshold to distinguish between like a normal contact and like a full-on collision?
Yeah, this is a good question, and there's a lot of nuance here. As I described in our automated scoring section, we are keeping track of certain collisions that we detect in the scene. These are collisions or contacts between the robot links and the surrounding, the table floor, the walls of the enclosure, and we're also checking for contacts between the plug that the robot's holding onto and other taskboard components. And we've done our best to model the wire. So modeling wires is a whole PhD field of its own. We've tried to make it as computationally effective for this competition as possible. We're not scoring participants or penalizing them for snags in the wire. This is something that we will keep a lookout for when we go into our qualitative evaluation. Right. So our expert panel of judges will be looking out for things like this in assessing the quality of the solutions.
And I assume that once they get to deployment hardware, if the cable hit a snag, then the policy will not work.
Exactly. And even in our simulation environment, if the cable does snag in any of the components, you should see a sharp reading increase in our force-torque sensor reading. So that should be some feedback to participants that something is getting snagged.
Thank you, Yadu. All right. Yadu, what robotics software framework are we going to use?
Yeah, we're building heavily on several open source frameworks here. ROS, Kilted Kaiju being one of them. We also have Gazebo that we're building off for our evaluation environment. We've provided some integrations with Mojoko and Isaac Sim, but really participants are free to use any framework of their choice. We don't want to restrict them.
Okay, that's nice. I think this question we touched about it, but I think it's important to repeat. Is the simulation environment homogeneous? For instance, if contact modeling is different across different simulators, will these different matter when we evaluate them on Gazebo?
This is a good question. We recognize that contact behaviors and physics will differ across simulators. We want to encourage participants to think of this as further domain randomization for their policies. These differences in physics could help them train robust policies that could help them succeed in the real-world insertion. And to kind of incentivize them to do this, our scoring is also set up such that it focuses on the ability to generalize. It's checking for whether the plug is coming close to the port, and the final insertion is just a bonus.
That's great. Okay, the next question is about what kind of sensor are the participants allowed to use, and can they design their own end effector? So in the toolkit, you will find the full bill of material. The setup that you're going to use across the challenge is pretty fixed. You're going to have a UR5E. You're going to have 3 Basler camera around the end effector with an ATI force-torque sensor and a pinch gripper. We will not allow participants to design their own end effector, and because we really want them to use the setup that we provide that is close to what we're seeing in the automation industry right now. Right, Yadu?
That's a good point, Jimmy. I think we've designed or constrained ourselves to use components that will actually be able to get into the field while balancing cost constraints as well. That becomes super relevant. And I will add that I encourage participants to think of this scene and the robot as something that's read-only. This will not change in our evaluation instance and something that's locked.
Right. And are all the information about the exact model of this hardware available on the toolkit?
They certainly should be in that scene description document.
Okay. So for phase 2, does this mean that the IVM, for those who don't know, it's an intrinsic vision model, should be used, or is it about integrating Team's train model into the ecosystem of IVM? So as you start at phase 1, you will get access to flow state and the whole of like the intrinsic platform capability, including the intrinsic vision model. And so you can use these resources freely to develop your end-to-end solution. And our intention is for participants to focus on the model for dexterous manipulation and insertion. And so you can use IVM to do other tasks, like detecting where the connector is before you pick it. You can use our grass planner and our motion planner to handle this like boilerplate task, and then really focus on the model. Is that right, Yadu?
That makes a lot of sense, Jimmy. So IVM and other capabilities in flow state will help participants reach that same initial environment setting that we have for the qualification phase. So they'll be very useful in detecting these components, grasping them, and perhaps getting close to that last couple inches of insertion.
Sounds great. Next question is, what AI tools can I use for translating the information of the toolkit? Or I like this question. Can I upload screenshots or images of the documentation to these tools to better understand the visual context and technical requirement? So I would say all the information that we provide to you through the toolkit, the website, is public, and you can use it however you want with your favorite AI tool to translate it to your native language or to give you more context about the requirement. Right?
Absolutely, Jimmy. I think one focus for us throughout the design of this toolkit has been accessibility and making it easy for participants to get started with. And one thing we also encourage is for them to use other AI tools to help understand information about the challenge better.
All right. So thank you for asking this question. And yes, please go ahead.
Yeah.
All right. I think that was the last question. Now, I think we received some questions live. We're gonna review them and answer them in our FAQ in order. I don't know if Jeff, you want to say a few closing words to the participant that joined us.
Yeah, I'd like to thank you all again for coming. It's been great having you here. Thank you to Jimmy and Yadu for such a detailed overview of the challenge and everything that the participants are going to face. And good luck, everyone. I'm looking forward to seeing the results.
Thank you, Jeff.
Thanks, Jeff. Thanks for joining. Good luck.
Thank you for joining. Good luck.